Hi, welcome to this video presentation by Unknown India YouTube channel. Please view it on a laptop or desktop or tablet for better video quality and use a headphone, earphone or earbuds for better audio quality. In this video, we shall explore the importance of green hydrogen to India and what steps are being taken by the Government of India at policy level and by public and private enterprises at the levels of action and implementation. All resources used in this video are referenced in the description below. There is a lot of hype about green hydrogen these days. So, what is green hydrogen and what are its uses? Before we answer that, let us look first at the present uses of hydrogen and how it is produced. Hydrogen is used in several manufacturing processes, for example, in producing ammonia, which is used to produce fertilizers for agriculture. In petroleum refining to remove impurities like sulfur. In metallurgy for reducing metallic oxides, for example, in making iron and steel and many other metals including copper. In food processing, for example, to produce fats from vegetable oils. In producing many organic chemicals like methanol and other compounds like hydrogen chloride, medicinal applications like hydrogen peroxide, etc. There are also several other uses like welding, production of flat glass, manufacture of electronics, etc. If we look at the predominant global usage of hydrogen, we find that 55% of all hydrogen is used in production of ammonia, 25% in refining petroleum, 10% for production of methanol, and 10% for all other uses that we have discussed. So, presently the predominant use of hydrogen is only for industrial applications. Almost the entire production of hydrogen today is from fossil fuels with attendant carbon emissions. Depending on the source of fossil fuel used, hydrogen is color-coded as black or brown corresponding to source being coal or lignite, grey denoting use of natural gas with full resultant emissions, and blue standing for use of natural gas but with carbon capture and storage. So these three color codes are in decreasing order of carbon emissions. But the advantage with green hydrogen is that it has no carbon emission in its sources or production process or its usage. The second advantage is that its energy density is 2.5 times that of natural gas and almost 3 times that of diesel or petrol. That is, 1 kg of hydrogen can give as much energy as 2.5 kgs of natural gas and about 3 kgs of diesel or petrol. It is produced by electrolysis of water, splitting it into oxygen and hydrogen. A large amount of electricity is needed for this process, and the generation of this electricity is from renewable sources like solar, wind, etc. In addition to the various industrial uses we just detailed earlier, green hydrogen can also be used for transport, that is passenger cars, cargo trucks, public transport like buses and trains. These are driven by a fuel cell stack in which pure hydrogen passes through a membrane to combine with oxygen from the air, producing the electricity that turns the wheels plus water vapor which is let out. There is no greenhouse gas emission at all. Hydrogen fuel cells can not only power road and rail traffic but even ferries and boats in inland waterways, as also container and cruise ships in oceans. These do not discharge harmful gases, thus protecting marine life and also boosting local fisher folks' economy. Green hydrogen can also be used in power generation, again using fuel cells, as substitute for fossil fuels, especially natural gas, thus eliminating the emission of carbon dioxide. The application can be for one of the 4 purposes, namely primary power, backup power, peak shaving, or grid stabilization. If green hydrogen has so many advantages, then why is it not already being used everywhere in industry, transport and power generation? What is the catch? Let's find out. The major challenge to quick and widespread green hydrogen adoption is its high cost, which is due to the high cost of renewable energy, the high cost of electrolyzers, and the high cost of storage and transportation. According to Bloomberg NEF, this will be brought down by the year 2030 to be on par with the cost of hydrogen produced with fossil fuels, and far below by the year 2050, as the costs of renewable energy, electrolyzers, hydrogen storage and transportation, etc. come down drastically, both due to the scale of economy brought in by greater volumes of manufacture of this equipment as well as greater competition. Hydrogen, as we all know, is very light, so to reduce the volume of storage, it is stored at very high pressures. This creates certain problems. It is also highly volatile and inflammable, therefore stringent safety measures are necessary in storage, transportation and handling of green hydrogen. For example, special materials are used in the construction of tanks storing or transporting green hydrogen so as to withstand the very high pressures. In vehicles, such tanks are crash-proofed. This is also the main reason for the high cost of storage and transportation of green hydrogen. Elaborate international safety standards are available for storage, transport and handling of green hydrogen. These need to be followed strictly, that's all. Therefore, this is not a very major issue. So, is green hydrogen important for India? What are India's priorities regarding green hydrogen? India has pledged at the United Nations Climate Change Conference COP26 held in UK in end 2021 to move to net zero carbon by 2070. India has also committed to reduce the carbon emission levels of 2005 by 33% by the year 2030. It has then revised this to 45% in COP28 held in United Arab Emirates in end 2023, when the pledge on net zero carbon was also reiterated. Apart from commitments to the global community, India needs to reduce its carbon emission levels considerably to avoid climate disorders at home as well as to protect the health of its own citizens. And this means that the percentage of power generation from fossil fuels has to be drastically reduced. Especially since India plans to be on a very high growth curve in the next few decades with major increases in power generation, industrial activity and transport intensity. If we look at the breakup of sectors contributing to India's carbon dioxide emissions of 2.2 million metric tons per annum, we see that three sectors, namely power generation at 51% of the total emission, industry at 25%, and transport at 13% add up to 89% of the total emissions. Therefore, these three sectors, namely power generation, industry and transport, in decreasing order of priority, should be selected for inducting the use of green hydrogen. Further, bringing down the cost of renewable energy is also a concurrent priority. So, what policy initiatives has the Indian government taken to facilitate quick build-up of capacity and adoption of green hydrogen in these three priority sectors? The Indian government adopted a national green hydrogen mission in January 2023. The mission is directed towards these outcomes by the year 2030. 1. Development of green hydrogen production capacity of at least 5 million metric tons per annum with an associated renewable energy capacity addition of about 125 gigawatts in the country. 2. Over $100 billion in total investments relating to green hydrogen infrastructure. 3. Creation of over 600,000 jobs related to green hydrogen. 4. Cumulative reduction in fossil fuel imports of over $12.5 billion. And 5. Reduction of nearly 50 million metric tons of annual greenhouse gas emissions. The mission seeks to achieve these goals using a three-pronged strategy, namely 1. Facilitating creation of domestic demand in multiple sectors such as energy, industry, transport, etc. Strategy 2. Substitution of imports of fossil fuels and fertilizers. Strategy 3. Promoting export of green hydrogen through cost-competitive production. Obviously, adequate financial incentives need to be provided to give a boost to all these three strategies and programs and make them successful. An interim fund of $2.5 billion has been set up for this mission. This consists of $2.2 billion towards strategic intervention for transition to green hydrogen, mainly through incentives for domestic manufacture of electrolyzers and for production of green hydrogen, and $300 million for pilot projects in 4 important areas, namely long-range heavy mobility, port and shipping, steel, and biomass to hydrogen, as well as for R&D. So, what project initiatives is India taking at ground level to implement the green hydrogen mission and strategy? Let us look at some of the projects of Indian public sector undertakings. The Ministry of Ports, Shipping and Waterways of the Government of India has commenced activities to construct 3 major green hydrogen hubs at 3 important ports, namely Deen Dayal Port at Kandla, Gujarat, Paradip Port at Orissa, and V.O. Chidambaranar Port at Thoothukudi in Tamil Nadu. These hubs will have large capacities of integrated green hydrogen production, storage and transportation facilities. The ports will also be made progressively green by utilizing the green hydrogen and renewable energy. India's first indigenously developed and built hydrogen-powered boat was launched by the Prime Minister Modi on February 28, 2024. This pilot project vessel was manufactured by the Cochin Shipyard Limited. It will be used for inland waterway transport at Varanasi. Based on the experience with this pilot project, several other waterways will also get green hydrogen-powered boats and ferries. 2 more areas of thrust for pilot projects in shipping will be retrofitting of existing ships so as to enable them to run on green hydrogen or its derivatives, and development of bunkering and refueling facilities in ports on international shipping lanes for fuels based on green hydrogen. Gas Authority of India Limited, or GAIL, a public sector undertaking, has started blending green hydrogen in city gas distribution grid in Indore, Madhya Pradesh, up to 2% by volume in CNG, that is compressed natural gas, and 5% by volume in PNG, that is piped natural gas. NTPC, that is National Thermal Power Corporation Limited, another public sector undertaking, has initiated blending of green hydrogen up to 8% by volume in PNG network, that is piped gas network, at NTPC Kawas Township in Surat of Gujarat. GAIL is also set to commission its first green hydrogen project at Vijaypur, a town in the Guna district of Madhya Pradesh, in April 2024. The plant will churn out 4.3 metric tons of green hydrogen daily from its complex. NTPC has also launched hydrogen-based fuel cell electric vehicle buses in the harsh climatic conditions of Leh in Ladakh. The first of its kind green hydrogen mobility project at an altitude of 11,562 feet is co-located with a dedicated solar plant of 1.7 megawatt for providing the renewable power. It has also launched similar buses in Greater Noida. Om Cleantech, a startup incubated by Oil India Limited, another major public sector undertaking, has developed a 9-meter hydrogen fuel cell bus that can cover 450 kilometers on a single refill. The bus has started plying on roads in Assam's Kaziranga National Park. Let us now look at some of the green hydrogen project initiatives by the Indian private sector companies. India's major engineering group, Larsen & Toubro, commissioned in August 2022 a green hydrogen plant of 15 tons per annum capacity for captive consumption at the AM Naik Heavy Engineering Complex at Hazira, Gujarat. It has an electrolyzer capacity of 800 kilowatts and is powered by a rooftop solar plant of 990 kilowatts peak direct current capacity and a 500 kilowatt hour battery energy storage system. In January 2022, the company signed a pact with Norway-based Hydrogen Pro AS to set up a manufacturing unit in India for electrolyzers. Another agreement L&T has is with Indian Oil Corporation separately to manufacture and sell electrolyzers. It has also formed a joint venture with renewable energy company Renew for green hydrogen business. In February 2023, Reliance Industries Limited and Ashok Leyland unveiled India's first hydrogen internal combustion engine technology solution for heavy-duty trucks. Later that month, Reliance, along with Olectra Greentech, which is a subsidiary of Mega Engineering and Infrastructure Limited, unveiled a hydrogen bus. Olectra Greentech aims at commercially launching these buses within a year. In July 2023, Reliance collaborated with Bharat-Benz for India's first intercity luxury concept coach powered by hydrogen fuel cell technology. It is also laying down the infrastructure for disbursement of green hydrogen from its proposed plant in Gujarat. On March 21st of 2024, TCPL Green Energy Solutions, a subsidiary of Tata Cummins joint venture, inaugurated at Jamshedpur, India's first manufacturing facility for hydrogen-powered internal combustion engines for medium and heavy commercial vehicles and other low to zero emission technology products in India. ACME Group has set up the world's first integrated pilot project for green hydrogen and green ammonia plant at Bikaner in Rajasthan. In this project, green hydrogen is being produced using a 5 megawatt peak from the solar plant, scalable to 10 megawatt peak. The plant will help in preventing approximately 4,400 tons per annum of carbon dioxide emissions. Many more green hydrogen projects in the Indian private sector are either being implemented or about to be commissioned. For want of time, we have only talked about a few prominent ones. We hope this video has given you a very clear picture about green hydrogen's importance to India and the various initiatives the country is taking to move towards its 2030 goals for green hydrogen. Please check out our other videos in the full playlist and also subscribe to our channel by clicking the respective links. Thank you.